I'll see the title of the talk, Blockchain Beyond Bitcoin. I'm going to make a wild assumption here. My guess is most of you have probably heard of Bitcoin. How many of you actually own any Bitcoin? Anybody? Oh, a few, okay. I will admit I actually do not own any Bitcoin. How many of you have heard of blockchain and understand the difference? Okay, so a few of you. My personal opinion, and what I hope to convince you of throughout this, and I'd actually love some feedback as we go, I think the blockchain technology is actually ultimately going to be far more interesting and far more transformative. I think Bitcoin is a very interesting use case of it, but it is one use case. I've seen a few people nodding already, so that's good. I've got at least a bit of a friendly audience. Have you seen the application for voting? I've heard of that one. I've not actually used it. So that's going to be a very interesting one. So applications for voting, applications for identity management, I think digital rights management and other things. I think it's really going to play a very large role in a lot of different areas. So what I will do in this talk is I will talk some about Bitcoin. I mean, I kind of feel like to understand everything about this, you need to understand what Bitcoin is and what it does. But I'll try to quickly get into what is the blockchain underneath it, how does it work, is there just one blockchain? And here I'll actually be interested in some of the people who've worked in this area. I think ultimately there will be several different blockchain implementations based on the needs of the individual environments. I'll go through what some of those might be, but I would love a bit of back and forth about that. Okay. This is a SNIA tutorial. The disclaimer is a little bit different than in most of the presentations here. I kind of read this over. You guys can read it over. It's in the presentations online and everything. But I think the basic summary is if you go out and make investment decisions or business decisions and they go south, it's not my fault. So. And it's not SNIA's fault either. Okay. So this is the abstract. Big thing about this. Blockchain technology is underneath this. First of all, they're distributed technology. What they do is they get a whole bunch of machines to get together and decide on what happened. Doesn't sound too bad, does it? How many of you are managers? Nobody? There's got to be a few managers. How easy is it to get everybody underneath you to agree on what is happening? It's a real, oh, you find it easy. You might be dealing with a chain. You could try beating them with a chain, with a blockchain perhaps. It's really difficult to get a whole group of different people, all of whom have different interests, to agree on what happened. What's transformative in my mind about the way blockchain works is blockchain solves that problem. You get this whole group of machines which don't really trust each other, running in a totally decentralized manner, and ultimately all come to agreement on here is an exact order of operations, exactly how they happened. And they all agree. Now, it takes them a little while to get there, and there might be some gyrations where they have some disagreements, but ultimately they get to the point where you can look at it and unambiguously state these operations happened in order 1, 2, 3. And that's got a lot of implications, as I mentioned, for not just money, it's clearly necessary for money, or I'll show it's necessary for money, but in a lot of other areas where trying to get cooperation across businesses or so on that are trying to agree on was product shipped and did you receive it? Did I receive my money for it? And those things, you need to have agreement between these entities that are kind of willing to trust each other and cooperate, but they're not fully trusting of each other. Did this actually happen, and in what order did it happen? And that's, I think, the really key part of this. Okay, so we're going to go into a little bit here. What are the difference between Bitcoin and blockchain? And the way this generally works is, Bitcoin is an implementation or a specific use of a blockchain, or one particular blockchain. It's a digital currency. What that means specifically is it's a currency that exists, in the ether somewhere. Why does Bitcoin have value? In essence, Bitcoin has value because people in this room and elsewhere think it has value. Actually, I meant to have a dollar with me. Why does the US dollar have value? Exact same reason. The US dollar has value because the US government says it has value, and, well, presumably everybody in here believes the US government. Maybe not everybody, but enough people believe the US government that that thing has value. Bitcoin is, in essence, the same way. It is not managed by a central government. So there's no single entity that can simply be pumping up more Bitcoins and producing more. I'll get into a little bit more exactly about, how many Bitcoins there are in the world. In essence, it's a fixed supply. That's a little bit of a simplification. I'll go into that later, but it's not that much of a simplification. It's all based around cryptography. Cryptographically signed documented evidence of who has spent what. Now, clearly, those kind of things are necessary for money. You need, a currency. It needs to have value. You need a way to prove, yes, that this is my money I'm spending. It'd be a really great currency from my point of view if I could spend all of your money and not mine, but that wouldn't be very good from your point of view. So you need all those cryptographic guarantees. But on the other side, there's a different set of attributes which are used to implement this currency, but where they have the value beyond just the currency. The blockchain itself implements that ordered list of records. Defined order, what happened, first, second, third. You can clearly see how that is necessary for money. If I am trying to spend money, and specifically if I'm trying to spend more money than I have to spend one set, and then the other one will fail. And everybody has to agree which one succeeded and which one failed. That's a clear requirement. It's distributed. Everybody globally can have a copy of it. They all agree on what it says. If I go to Japan, I don't have a different view of my money than I do here in the United States. It has to be completely decentralized, completely distributed. And I put in here self-policing. There are mechanisms in place to make sure that nobody is abusing the system. What's interesting is those same kinds of characteristics apply in a lot of other situations. Okay. How do some of these things work? How does this technology provide these guarantees? This is a simplified view, ultimately, of what a blockchain looks like. In essence, what you can see is this ordered set of transactions, where in each of those blocks, the top transaction happens first, then the second, then the third, and so on. The blocks themselves are ordered. So this one over here with ZKJDAA on top, that is the most recent one. All of those transactions occurred after transactions AA, AB, AC, and so on. They all occurred before transaction 1, 2, 3, which occurred before a different set, and so on. And if you're like me, you kind of work this out, and you're like, well, where does this end? Or where does it begin? There is a special block called the Genesis block. That was the very first one that is put in there. The special thing about the Genesis block is it has no predecessors. That's why it's the Genesis. And that's where everything starts. Every block after that references the previous block in the chain. And in that way, you can build up the entire chain, and you can see across all of the systems exactly what transactions happened and state categorically in what order they occurred. So how do we go and add more transactions to this? What happens when I or somebody else wants to spend some money or add a new record? First thing I do is I generate that information. I then go actually sign it at this point with a private key specific to me to prove that I did this, and I send it to one or more machines in the system. In this case, I'm just showing one for the sake of simplicity. And that machine is going to check and make sure, yes, everything looks okay here. And he's going to start, he checks if it's valid, assuming it is, he's going to start creating a new block. Now, if you notice, all these other blocks all have more than one transaction. That server there is getting these transactions not just from that one person, but from tens of thousands of others, grouping them together into a new block, setting it up, and then he's going to try to add it to the blockchain. Now, adding it to the blockchain isn't quite as simple as saying, well, I'm going to put, the hash of the prior block in there, and then I'm done. What I have to do to add it in there is I have to go through and I have to calculate the hash of this block. Now, if you're familiar with hashing algorithms, you should know that's a really simple thing to do. You run an algorithm over it, it'll probably take, 10, 20 milliseconds or something like that. But the trick about it is the hash of that block has to match a specific pattern. And the typical pattern it has to begin with a certain number of zeros. I don't remember what the exact numbers of zeros is now. It's in the order of 10 or 20 or something like that. But why that is difficult is there is no good way to predict, given all the transactions that are in that block, how I can make it come out with those values at the beginning all zero. And what I wind up doing is I wind up basically setting up most of the block and I have this value in here called a nonce. And I just basically put random numbers in there. Maybe not totally random, maybe I try to sequence them or something like that, but I keep putting different values in there and retrying the hash and hoping eventually I will get a hash that has the right number of zeros up at the front. When I do, that's when I can go and I can add it into the blockchain. That may seem really weird why I need to do that, We'll talk in a little bit about exactly why I need to do that and what problems that particular mechanism is there to prevent. It's a feature. Once I do that and I have figured it out, then I can add it to the blockchain. But at that point, I'm the only one who knows this. It's not a really good distributed ledger that everybody agrees on if I'm the only one that knows about this new block. So I need to go and I need to tell a whole bunch of other people or a whole bunch of other servers, here's this new block that's at the end of the blockchain. And they can also go, they can tell their friends and so on, and fairly quickly that will spread throughout the network, and people will agree, yes, we agree this is a valid addition to the blockchain, and we accept this. Now that's kind of the basics. Now if you remember when I said earlier some of the things about everybody winds up agreeing, it's decentralized and so on, I haven't really covered, what could go wrong in this or where could people attack this. So why does this actually work? What are some of the more details? When that person sets up the transaction initially, they do cryptographically sign it. This is typically all done with a public-private key infrastructure. So not only do they set their transaction, they sign it using their private key. So anybody in the world can validate, yes, this transaction could only have come from that person. They also have to say where they got the money from. And this is to prevent double spends. They can't just say, well, I'm going to spend 10 Satoshis. A Satoshi is a fraction of a Bitcoin. They can't just say, I'm going to spend 10 Satoshis and trust me, I have it somewhere. They have to say explicitly, I received these 10 Satoshis from this transaction, or maybe I received 12 Satoshis from that transaction. I'm going to spend 10 of them by handing them over there, and the other 2, maybe I'm going to keep by transferring them back to myself. I have to be extremely clear about exactly where I'm getting that money. And one of the reasons that's important is when this guy goes to check is it valid, he's going to go and he's going to check that transaction where I said I received that money. And if he sees in the blockchain, oh, that transaction was already spent, therefore you are trying to cheat me, this is invalid and I will not proceed. So you have to have that clear chain in there, and this guy is going to check if it's valid. But then what happens if this guy fails? He does the check and then he fails. Well, I'm still trying to spend my money, and presumably it is a legitimate transaction. So really, I don't normally send it to just one of those servers. I send it to multiple because I want to make sure at least one of them is going to be able to pick it up and process it along. That'll come into play later when different machines are trying to add new elements to the blockchain and how they wind up agreeing. But so he checks and says, is this valid? He checks the signature, he checks the transaction, he sees, yes, everything looks kosher. Presumably he does. If he doesn't, he just pitches it and that's the end. Okay, we go through, we're creating the new block. Again, have to have that pattern where it begins with a certain number of zeros. Right now that's set, should take on average about 10 minutes to be able to populate a block and have that hash in there that matches that particular value. And again, that's in about 10 minutes. Every once in a while, they'll come in shorter. Maybe it'll be 5 minutes or something like that. Every once in a while, it'll actually take longer. It could take 30 minutes or 40 minutes to find that right set of values and get that next block in the chain. So it's a little bit random, but basically that hash pattern is set of what that hash value has to match to make it happen about every 10 minutes, given the current speeds of computers and things like that. Okay. So then comes the interesting part. I've tried to propagate it to everybody else in the world, and this is where a few interesting things can happen. Let's assume throughout this it is truly a valid transaction. It was picked up by one or more systems. They looked at it, they added it to a block, and let's say for the sake of argument, more than one system found that right combination of transactions and the nonce and so on to get the hash to match the valid pattern. Normally that doesn't happen. Normally it's only one person at a time, but let's say for the sake of argument, 2 machines find that, and they both start pushing out that transaction and saying, I've got a valid block. Well, what happens? This is one of these cases where I mentioned where people may not, or the systems may not all agree right away. They will ultimately, but at the moment, they've got 2 different sets of transactions which may form the next block in the chain. They are both perfectly valid. They both look good. The problem is in one of them, I've spent my money, and the other one I haven't. And I'd really like to know have I spent my money or not? Well, what happens in this particular case is there's a rule in blockchain that says if there's ever a case where there's a fork in the blockchain, where there are multiple valid next blocks, ultimately the longest chain is going to win. So what will happen is temporarily we have this fork in the blockchain because two systems happen to find a new block at right about the same time. Well, other systems are going to view this and they're going to say, okay, I'm going to mine on top of one of those. And it's a little bit arbitrary exactly which one they choose to mine on top of. But what's ultimately going to happen is, it was a small chance in the first place that two systems mined the next block very, very close in time to each other. What are the odds that's going to happen again? That's pretty slim. Again, it is possible, but it's pretty slim. But you can see over time, ultimately one will happen where a new block is mined on one of those forks, and it makes that fork one block longer. That change gets propagated out, and all of the systems in the blockchain that had the shorter fork and were mining on it will say, oh, there is now a longer valid fork. I'm going to abandon my efforts over there, and this is the new blockchain, and this is the one I agree on. Now, what can happen in those kind of situations? A couple of things. One of which, the money I was trying to spend, whatever I was trying to spend it on, may have been in that short fork that ultimately got abandoned. So I thought for a little while I spent my money, and then I found out, well, no, I really didn't. But the systems that created that block initially still remember my transaction, and they can put it back in and try to add it in at the end of the now longer fork. And ultimately, it will get added, and I will have spent my money. But you can't necessarily assume it's permanent when it's just been added at the end of the blockchain. The typical is you need to wait for about 6 blocks to be added afterwards. Then you're pretty certain all the forks have been resolved and so on. Now you're certain that that block is valid and it's not going to change. A couple other things about this. Why are there systems in here that are doing this? Do people just set up these systems because they're friendly and because they like Bitcoin? Some people probably do. There are 2 ways that Bitcoin really encourages people to set up these systems. And basically, in essence, it's bribery. They pay them to set up these systems. Every time a new block is created, there is what's called a mining reward, which is paid in Bitcoin, to whatever system actually created that block. Now that's a value, it started at a certain level, it's been halving over time, and it's ultimately going to go to 0. And when that reward goes to 0, the supply of Bitcoin is going to be fixed. So no inflation or anything else will have a finite number of Bitcoin at that point. Up until then, the supply is rising. So people get paid by those mining rewards. The other way they get paid is by what are called transaction fees. A transaction fee is simply when I spend money, in this case again, say I'm trying to spend some money, I received 12 Satoshis from a transaction at some point. I'm trying to spend 10 of them because I'm trying to buy something. The other 2, I could send back to myself, or basically I could leave the other 2 as a reward for whatever miner includes that in their transaction block. And the reason I want to do that basically comes in from the self-interest of the miners. If the miners are looking at a list of thousands of transactions that they could include in their next block, and some of them give really good transaction fees, and some give really chintzy ones, which transactions would you include? The ones with the bigger fees. So those fees are designed that even after the Bitcoin mining rewards are all gone, those transaction fees encourage the Bitcoin miners to include the transactions, and that's how they make money. So it's self-interest. In essence, those miners are being paid for the electrical cost, the computing cost, and everything else, all the time they have to do this, and they are getting that as a reward. Okay. So is all of this really necessary? Now, clearly, I think hopefully I've convinced you that this does work. It prevents the problems. But why the 10 minutes? Why the proof of work? Why have this all be quite so difficult? The reason for that, again, I won't say difficult, or it's a feature. The reason comes in Bitcoin is based on the fact that the systems in it do not trust each other. Anybody in the world can set up a Bitcoin mining node. They can speak the right protocol, Presumably, if they are a friendly person, they will implement it all correctly. However, as in the case, I think, how many people here have ever heard of financial fraud? Yeah, banks doing the wrong thing or other people doing the wrong thing. When you're dealing with money, there's a huge incentive to break the rules if you can make money doing it. Well, what prevents me from breaking the rules here and doing what's called a Sybil attack? A Sybil attack is one where I slip a node into the network that looks like it's a nice node. It speaks the right protocol, it seems to behave in the right way, but really it's a rogue in there and it's doing the wrong things. With a Sybil node right in there, I could basically attempt to forge a transaction. Well, the problem is with forging a transaction, I do need to know the original signatures. Okay, they're hard to forge. I could try to spend money twice. I could try to repeat transactions and generate blocks very quickly. But the problem with that comes in that 10-minute proof of work. I can try to spend a transaction, send it out over the network, and then I can try to generate another block reusing that same transaction. But the problem is I can't generate that other block very quickly. On average, it's going to take me about 10 minutes to do that. It may take me longer. It may take me 20 minutes or 30 minutes to get that right combination. And by the time I have done that, probably somebody else has come in and mined a different block. So it is very, very difficult for me as a rogue to add enough new information into the blockchain and do it in a fraudulent way because of that proof of work. I have to have those on average 10-minute periods, and that's plenty of time for other people to get in there, look at the state of the world, and validate, does this make sense or not? Now, one of the things that could happen, again, this would be practically speaking impossible, but if I have enough of these systems and basically I can have 60, 70% of the mining power in blockchain, then theoretically I could do this. Because I could have enough of these cooperating nodes that they trust each other, don't check each other, and push these changes out. Realistically, this is where the decentralized nature comes in. In all probability, even if there are lots of people who want to put these in, they're not going to cooperate with each other. Because I want the rewards for myself, and there's a bunch of dishonest people over there who want the rewards for themselves. They want it for themselves. None of us is going to get over 50% of the computing power.
Well, except for most of it is in China now.
That is an interesting point. The way this has worked right now, a lot of the Bitcoin miners are in China at the moment.
One reason why Russia's talking about subsidizing.
And that's where you get other actors who are coming in to try to prevent that. It could change into a James Bond film, but you're kind of seeing the point. It's theoretically possible if you're up over 50% and you're cooperating. Realistically, that would be hard to do. And that's especially where all that, harder and harder as time goes on. And that's why those mechanisms are in place, especially around that 10-minute proof of work, because that makes sure that you can't just willy-nilly add things very quickly. It takes a lot of effort, and it would take a huge amount of cooperation in order to really manipulate this. Okay. That's how blockchain works underneath Bitcoin. Again, hopefully you can see how that works for Bitcoin itself. However, what other kind of things are there in the world where we really need that ordering? Yeah. Oh.
When you were doing your research for this, did you get any sampling of how many cryptocurrencies are currently in existence?
I did look into that some. I don't remember an exact number. Yeah, it's quite a few. Bitcoin is clearly, I would say, the most well-known, but there are other ones. There's Zcash and things like that. I think you said it was over 300 at this point. 800.
Our market cap tracks over 800.
Okay.
But
So.
some of them are duplicates, some of them use the same chain and use different technology and things like that.
A lot of them are similar.
Yeah. So, but basic point of that being, I mean, here I talk kind of exclusively about Bitcoin in the context of the blockchain. That's an example. I would argue, and I think this would be a fair statement, Bitcoin is the most well-known of the cryptocurrencies, but it is far from unique in that sense.
Value in the name and Satoshi's not the same brand.
Oh, right. Okay. Where am I? Okay. But so what other kind of things need, again, or could take advantage of that agreement amongst decentralized parties and agreed order of what happened? And yeah, animation went a little awry here. But imagine things, property deeds. How many of you, probably a bunch of you, have bought a house, had to do things like title searches and so on? What's a title search? It's a sequenced order of who owned this house over time. It's a pain in the neck because it's all stored in paper records and things like that. Well, what mechanism do we have to store an ordered set of records? Oh, maybe a blockchain. How about things like artwork? If you want to forge artwork, typically you have to have papers that you typically forge also that show where that artwork came from. What if artwork, as it was sold and so on, was stored in a blockchain, available everywhere? It'd be much, much harder to forge those identity papers and claim this is a valid piece of valid Picasso when all the Picassos are known via records on a blockchain and who owned them when. Same thing, car title and ownership, medical history. Medical history, I think, is a really interesting one for a couple of reasons. Partially, it is an ordered set. I had these tests done at these dates. You can see the progression. Do my medical records belong to my medical provider? It's arguable. Clearly the medical provider needs access to them, but really, I'd like access to them too, and I would like to have that record associated with me. When I switch medical providers, there shouldn't need to be transferred amongst them. If they're decentralized and I give permission to a new medical provider to view them, they could go ahead and look at them. So this would make the portability of things like medical records, the non-forgeability, much, much easier, open up a lot of new possibilities. And it comes down to that fact that this allows people who don't necessarily have to trust each other to work together and agree on exactly what happened in a non-forgeable way. So, we've talked about blockchain, we've talked about the particular Bitcoin blockchain and how that works. We've talked about a few other applications that can take advantage of that ordering. Now, this will be hopefully an interesting part of the presentation. You take a look at that picture. Is that a potato or a potato? And my point is, both are right. Now, in this particular case, it doesn't really matter whether you say potato or potato. In the case of blockchain itself, there are certain assumptions made for the Bitcoin blockchain that drove its behavior in those situations. And what's interesting to me is there are a few different blockchain implementations that are arising that basically tweak a few of those assumptions. It makes them less suitable for cryptocurrency, but I think it makes them more suitable for some other cases. And we'll go through some of what those changes might be, the advantages and disadvantages of them. Okay. So what do you need to make a distributed ledger? What are sort of the key things that you really need behind that? One of them, you need the protection from forgery. If it's a house sale, spending money, a medical record or whatever, you need some way of validating when that record comes in, yeah, this really is a valid record and it's not somebody just randomly pushing it in or making something up. Pretty much everybody uses asymmetric key encryption, the public-private key pairs with the signing and so on. I suspect there are some other ways to do it, but for the most part, everybody seems to be going that route and it seems to work very well. You need a way of distributing the information. Once you've added the information onto the end of the ledger, again, it doesn't do anybody much good if you're the only one who knows that. You need a way of propagating that information out, and you need a way of knowing who do I propagate it to. You're not just going to randomly send it to IP addresses and hope somebody was interested. You need some way of knowing who else is managing this blockchain so I can get them the information. That plays into the redundancy in the network. You absolutely want to make sure that if a single node goes down, it doesn't bring down the blockchain and nobody can do anything. In fact, you'd really like it that if like half the network goes down, you can still proceed with the blockchain. It needs to be extremely redundant in order to be reliable. The decentralization comes with that. The more decentralized you are, that helps with the redundancy. Then what I call the internal fraud protection. They're basically protection against Sybil attacks, against buggy clients, things like that. Anything that could go wrong that would impede people or impede the systems from coming to consensus. Whether that's somebody truly being malicious, or again, if it's simply there's a bug in one client, you can't have that bring down the system. So some way the system can police itself and make sure that, yes, everything is correct. Now, a bunch of this we've seen already. For the blockchain Bitcoin, or the Bitcoin blockchain, how does it do it? The forgery uses the asymmetric key pairs, the public key infrastructure. The information distribution is a point I didn't really talk about earlier, but there is an element of the protocol in that blockchain that you basically broadcast other blockchain nodes. You hear about other blockchain nodes, you broadcast them out. When you are broadcasting out, I've just mined a new block, you use those lists of, okay, I've heard about all these other blockchain miners, I'm going to send out this new block to them, they can forward it, and it tends to propagate very quickly. It's like a gossip style protocol. You tell all your friends about what you've heard, they tell their friends, and pretty soon it's spread throughout the world. The redundancy and the decentralization, well, here I say they come from the mining rewards. Really, it's the mining rewards and the transaction fees. There's a monetary incentive for people to set up new nodes that are trying to mine new blocks in the blockchain and to set them up in all over the world. So you get the redundancy out of that, and also you get the full the decentralization, because they pop up everywhere because everybody is looking for some of that money. Then the fraud prevention, that proof of work. I can get in there, I can introduce a buggy client, I can introduce a malicious client, but I'm still bound by those 10 minutes of how frequently I can generate those blocks and how much damage I could do in that time before somebody else discovers I'm doing the wrong thing. So that's one way to do it. Another example is something called HYPERLEDGER. HYPERLEDGER is being set up. It's an open source project. It's being looked a lot, especially basically a consistent key value store used for what's called business-to-business contracts, what are called smart contracts, and things like that. It does things in a slightly different way. The forgery protection, again, still use the asymmetric key pairs, but the next three are interesting. How it actually does the redundancy, decentralization, and so on. The way HYPERLEDGER does things is it has what's called a whitelist of nodes. It's got a membership in there that it says, okay, here are the nodes that I'm aware of that are participating in this HYPERLEDGER. If you're not in that list, you don't get to participate. You could try, you could chatter, you could send me stuff, it's going to be ignored. There are a couple of advantages to that. You have the information in one place. Presumably the people who are participating in the HYPERLEDGER, they're interested, maybe they're one of the parties in the business-to-business transaction, or there's some other reward. By its nature, people will set up enough systems to help implement this. If it just so happens, say it's two companies in the United States that are collaborating with each other, maybe there are no servers in Japan. Okay, but maybe they don't care. If they're never going to go to Japan, they don't need it in Japan. So the decentralization and the redundancy are driven by who's actually participating. The way they do the fraud protection is, again, part of that whitelisted node using something called practical Byzantine fault tolerance. That's a mechanism. It's basically a way that if you can get 2/3 of the group to agree on the order of things, you can declare it a decision and move on. Now, actually, let me make one or two points and then I'll get to you. There are a couple of interesting things about this. The thing about, especially the practical Byzantine fault tolerance and the rest of this, it can be much faster than the blockchain for Bitcoin. Practical Byzantine fault tolerance depends a bit on network speeds and so on, but they can come to agreement in seconds or sometimes sub-second. So you can add things and have it process things much more quickly. The huge downside, though, comes from that whitelist of the nodes, because suddenly you've got to trust somebody. You can't just have people arbitrarily set up nodes because they don't trust the ones that are there. You need to have that element of trust in somebody, that somebody is managing that whitelist and is vetting those systems and is making sure they're okay. And again, if you are trying to do a digital currency like Bitcoin, who are you going to trust to do that? You're not going to. This solution would not work for a true digital currency like Bitcoin. However, if you are two businesses, you're coming together, maybe there's a third party you both are willing to trust to a certain extent to manage that whitelist. You give up some of the protections of a blockchain, of a Bitcoin-style blockchain, but you have much faster access and much faster updates. So that's a trade-off. Are you willing to have that small degree of trust or not? In some environments, I would argue that degree of trust is okay. In other environments, I would argue it is absolutely not okay. I think you had a point you were going to...
I was going to say, I consider it a tax service.
That's a fair way to look at it. That whitelist and who's managing it, that is your point of attack. If you can compromise that system, basically you can take over and do whatever you wish with the system.
Compromise or simply influence.
Yeah. And that is, I would agree completely. MultiChain is another one, and again, it basically comes down to a very similar attack vector in the end. MultiChain, you basically have a named list of participants. It's actually stored on the MultiChain blockchain. But again, it's not as secure as in the Bitcoin blockchain. It uses what's called round robin, where basically amongst all the nodes participating, you basically alternate between them of who gets to mine the next node. The distribution and so on, again, presumably, if there are this list of systems that have been added to the multi-chain blockchain, they're there because they're interested in the results. And again, they're somehow collaborating. It becomes redundant and decentralized by the nature of who is actually collaborating, and they have an interest in doing that. It's not going to be as decentralized and redundant as, again, a blockchain for Bitcoin, simply because of the nature of it. But again, if I have a number of companies collaborating in the New York City area, the fact that all my nodes are concentrated in the New York City area is probably not a huge problem. For money, a cryptocurrency, that would be a huge problem. But again, the round-robin mining can be much faster for the updates and so on. And it comes down to, again, are you willing to have that small bit of trust into the node management? And in some cases, again, I would argue it's fine. In other cases, it's absolutely not.
So with the round robin mining, what happens if the miner whose turn it is offline?
So the question was in round robin, what happens when the miner whose next turn it is offline? Believe the way it actually works. I need to go back and double check this, but I think the way it works, there's got to be I'm trying to remember if there's a timeout or if it's more of a system where, if you've mined the block in the last whatever, you can't mine the next one. So I don't know if it's quite a strict round robin or, once you've mined one, you have to wait to mine your next one. Yeah. Could be. Again, certainly multi-chain, it's open source, it's all available. I'd have to double check. I remember when I looked at it, I saw enough to say, okay, I can see that makes sense, but then I've forgotten it. And this gets back to, what are the different ways to do this? Blockchain uses, or the Bitcoin blockchain uses that proof of work. We've talked about that. We've talked about round robin, some other strategies that have been proposed. There are things like proof of stake, where basically the idea behind that is, as you participate in a blockchain, you build up an interest in that blockchain. And that's called, in essence, your stake. And what that proof of stake is, the more you've invested in the blockchain, the more likely it is you are able to mine the next block. And again, this kind of comes down to self-interest. If I've invested a lot of computing time and resources and so on into a particular blockchain, I have a self-interest not to destroy that blockchain, because then I destroy all the value that I have in that and all my investment in it. And so by doing that, you basically, the people who've put the most in get to mine the next blocks. Similarly, proportional previous mined blocks, it's a similar strategy. The longer you've been doing this, the more trusted you become, the more likely it is you get to mine the next block. And again, certainly none of these are foolproof. You could get in there like a Trojan horse and pretend to be a good citizen for quite a while and then show your true colors. But again, they're a way that they try to do this. They still require that bit of trust. And again, the other one I mentioned, the practical Byzantine fault tolerance, that capability to say, okay, protocol to get at least 2/3 of the participants to agree, and once more than 2/3 have agreed, you can push forward with that as a decision. Clearly that, again, it's vulnerable to the Sybil attacks. If I can just add more nodes into the system, before you know it, I can control 2/3 of the systems, and then all bets are off. Got to be controlled by that whitelist, which again requires that bit of trust. So in my view, as you kind of put all this together, where does this lead to? We've seen a bunch of different ways of implementing this distributed ledger, this distributed sequence of transactions. Different trade-offs you can make, which generally rely around, are you willing to put any trust anywhere in the system? If your answer to that is no, you really need a Bitcoin style with the 10-minute proof of work, provides great guarantees against malicious clients and so on. If you're willing to have a little bit of trust in parts of the system, you can implement some of the other mechanisms. But either way you go, once you have that underlying mechanism, things like identity and so on become very interesting. I assert I'm Mark O'Connell. I came up here, that was on the first slide. Presumably you all believed me. Why do you believe me? How did I prove it? I never did. You simply happen to believe me because most people aren't liars. I could store identity on a blockchain. I could have, create a record when I'm born with a private key, put that on the blockchain that says this private key belongs to Mark O'Connell. I wouldn't actually put the private key there, I'd have a signature and so on. As I go through life, that could become my identity that is provable. When I turn 18 and I'm eligible to drink, the government or somebody else could issue a signed certificate that's associated with my identity saying Mark O'Connell can drink. I can go to a bar, instead of having an ID card that is easily forged, that also gives away my birth date and other personal information, I can produce this certificate that says the government has certified I'm able to drink, and I can certify I'm Mark O'Connell. Haven't given away any personal information, but I'm allowed into the bar. Same thing with driver's licenses. I could use it for Facebook accounts and so on. Can manage an awful lot of things in this cryptographically provable way. Business-to-business transactions. Two different businesses or multiple businesses cooperating with each other, supply chains and so on. The issue today with all those kind of supply chains and so on is where do you store the information? Either company likely has their own database where they keep track of that. They're not going to expose that database to the other company because there's not full trust. There's a degree of trust between the two companies. They are doing business with each other, exchanging goods and money and so on, but it's a bit of trust at arm's length. Well, they could store common information in a blockchain. They both contribute nodes to it, so they both have an interest in it. Defined order between them of exactly what happened, completely incontrovertible. Also plays into what's underneath called smart contracts. Smart contracts are a way of automating transactions. It's basically a way, especially the Ethereum blockchain, for those of you who know that, makes heavy, heavy use of this. A way of basically putting code in the system that can execute, generates, cryptographically secure results on the chain that says, well, when I've seen these 2 or 3 things happen, this next thing happens, and it gets added to the blockchain as a result. A voting example was raised earlier. You can use variants on smart contracts to track people voting, things like voter fraud and so on. Well, in order for me to vote, I had to certify I am Mark O'Connell with that initial signed authenticated result. Nobody else can go in and claim they are Mark O'Connell. If I go in and vote twice, well, both votes are going to go on the blockchain, and you're going to look and say, oh, well, this first vote is valid. This second vote isn't. We'll pitch that. Voter fraud and things like that, non-existent. Digital rights management, we have mechanisms around this. But what if, I don't want to watch a movie on Netflix? Yeah, actually, I will admit, I do use Netflix streaming, but I also get DVDs on Netflix for some of the things. What if instead of getting a DVD in the mail, Netflix pushed an entry on a blockchain that said, Mark O'Connell has rights to view this movie? Suddenly, I could view that. When I'm done, I tell Netflix, they push a new record that revokes that. Save all the postage costs and so on. Can multiple people view that movie? Nope. There's a record that says I'm able to view it. If there's a second record pushed on at any point, well, I'm still the one able to view it. The others are invalid until my viewing rights are revoked. And once my viewing rights are revoked, if I try to view it again, all those records are in that blockchain in order, and you can see, oh, you're not allowed to view that anymore. Your rights are revoked. And I think these cases, I'm sure there are millions more, are going to be much more transformative in how blockchains are used. I think ultimately, my personal view here, and again, I'll open up for questions in a second, is there going to be one blockchain implementation? I kind of doubt it. I think the Bitcoin blockchain, with its strong guarantees, lack of trust, and so on, I almost view that like a backbone. It's going to be underneath it, but there could be other chains that are built, maybe that occasionally push information to that, but are used for smaller, more localized purposes, where you don't need the full security of the Bitcoin blockchain. Some of those would be like the Netflix case and so on, where maybe I have a personal blockchain with Netflix. Maybe with my bank or things like that. People talk about foreign exchange, again, housing, title properties, and things like that. I think ultimately there'll be a lot of use cases for this, and I think there will be different blockchains for the different purposes, making different trade-offs about the security and so on. So that is the end of the talk. Would definitely, one of the advantages of being at the end of the day, I'm happy to take questions as long as people have them. Also happy to stand outside afterwards. Thank you very much for your attention, and I'll open it up. So the question was, am I seeing use cases for either storage systems or file systems to use the blockchain? The answer to that is I'd say mostly a yes. Specifically, I wouldn't necessarily see a use case where like a file system or things like a storage system would actually store their data on the blockchain. But one of the interesting things that I have talked about in other contexts has been, again, merging this with identity on the blockchain. And one of the interesting things I thought about is a storage system where it gets its rights on the different files and so on underneath it, not from records that are stored on that, but basically based on identities in a blockchain. With the advantage being that I could store a file in a file system somewhere, signed by me, Mark O'Connell, and give rights to me and a few of my friends. And maybe that particular file migrates elsewhere throughout the world. I can go to a different system and say, I am Mark O'Connell, or maybe I'm a friend of Mark O'Connell's, and I want to look at that. It can validate that identity on the blockchain, look at the access rights and say, okay, I see you do have access rights to that file. And that way we can have basically use decentralized identities as a security system. So the security is not tied to an individual storage system, but almost a more global level. And that's something also, I don't know if people here are familiar with IPFS, I think it's the Interplanetary File System. I think there's some very nice tie-ins there of how you can manage security. IPFS basically tries to put a file system, decentralized file system across the globe. Integrate that with decentralized identity, and I think it becomes very interesting. Yeah.
There is this product, the storage, where you can run your overcapacity to others.
Oh, okay.
You use the blockchain.
Oh,
Erasure coded system, you get paid out and
yeah.
In Firefox.
Oh, really? Okay. I think I have her. That's Storage or Storage Day or something. Yeah, yeah. So the statement was there is a company or Storage where the basic idea is, most people have extra space on their local systems. And the idea is you can rent that space out as storage space for other people. And the way that all works, it's all based on a blockchain. And you get paid for that storage space and so on. And that's another interesting use of how you can use the blockchain in a very different way. Yep. Yep. Yep.
For non-currency blockchains like identity or voting, what do you think would be the equivalent of mining nodes to encourage people to add more money?
Right. So the question would be, for a non-monetary blockchain, what's the incentive for people to add new nodes to the system? It's a very good question. I think there really depends on the use case. Like I could imagine one, say, medical records, where lots of people could be interested in the medical records. Clearly, I as an individual have an interest, but the medical providers, they all have an interest in that. Medical researchers, I think, could also have an interest in that. And here, I think especially when you get into some of these use cases, again, you could imagine a lot of interesting things. There may be enough interest between the medical community and the researchers that they fully fund that, and I as an individual don't have to. Now, do I have to give up anything? Maybe I have, put in requests that say, okay, things like my dental x-rays. Maybe dental x-rays are a bad example, but you can imagine a number of things. I agree that people can look at anonymous copies of my dental x-rays for dental research. We could set it up that, okay, they can't get my name or anything like that. They can't contact me. But if they are looking at, rare conditions, they can pull this information. In exchange for them being able to do that, they are funding that blockchain and keeping it going. Same thing one could imagine with liver conditions or other things like that. Voting records, I would imagine a government would fund that. And again, they would have an interest in making sure that is decentralized at least across the country. Business to business smart contracts, I would imagine the different businesses that are collaborating, again, they're going to have an interest in setting this up and making it work. So they're going to put some skin in the game. So I think there are various possibilities like that that are not so directly related to it, but if you are looking to get the benefits from this, you're going to be motivated to make this work. In the back.
You talked about safety and actions to prevent fraud.
Yep.
Can you speak about a bit what happened in 2013 with Mt. Gox? Are there any actions to prevent such things?
Right. So the question was, in 2013, Mt. Gox, I will admit I hadn't looked into that. I remember the situation that occurred. I don't know if there's somebody here who is more familiar with it off the top of their head than I am.
Well, when you give your crypto to Mt. Gox, it's not yours.
Well, yeah.
So it wasn't a failure of Bitcoin, it was a failure of
They had the, Mt. Gox had the private keys.
Ah, okay. So that was the situation. Mt. Gox had the private keys. That's actually, it's a point I did mean to mention. All this asymmetric key encryption and so on, relies typically on the private keys. The private keys have got to remain private. If my private key is ever compromised, somebody else can claim they are me, and they will be able to prove, hey, I have access to that private key. And then all the rest of the mechanisms, you're not really defeating the other mechanisms. The other mechanisms are working as intended, but it's just if I don't safeguard my private key, all bets are off.
Well, that's why the identity management is going to take a while to take.
Yeah, it's an interesting thing because with the identity management, once your identity is on the blockchain, I did kind of mention, a lot of problems are solved, but it comes down to the fact, how do I safeguard my private key? Because once my private key is compromised, somebody else can claim they are me. And again, because everything then is based on that, it'll simply be believed. So there's a very, I think, interesting area of how do you really safeguard your private key? What can you do about that? Where do you store it? Yeah. My personal feeling is I wonder if it's going to go something like biometric or something like that, really associated with me. I don't know. That's me truly kind of speaking off the cuff there. But the private key issue is, I think, a really ripe area. Yeah.
Could you talk about throughput, not necessarily in context of the Bitcoin blockchain implementation, but more generally as well, some of the more special purpose systems? What expectations of throughput or number of transactions that can be recorded in distributed ledger are you seeing in the future could be used for things like cloud systems?
Right. So the question was about basically throughput. How many transactions per second can realistically be added into one of these blockchains? And again, they're clearly like the Bitcoin blockchain. I know you said not to do that, but I'll answer that side first. With the 10 minutes and so on, it's got a defined block size. It was a megabyte. Some of the blocks are now at 8 megabytes. There's a bit of a discussion about that. But that 10 minutes and the block size are a fundamental limiter on how many transactions can be pushed through that system. With these other systems that use basically a faster mechanism of consensus at the cost of some trust, it's going to be bound simply by the speed of the networks, how quickly you can get them in and validate them, and so on. Realistically, how many you need is really going to depend on the use case. For something like, I don't know, say identity or something like that, people are born, however they're born, but once a lifetime. It's going to be read a lot, but it's going to be updated far, far less frequently. Even if during the course of my life, at various interesting points, like when I get a driver's license, when I buy a house, other things and so on, I'm going to be updating my identity, once a month, once a year. So even multiplying that by, all the entire population of the United States, it's not that huge a number. Things like, business to business or smart contracts, that's where you can get much higher rates, where potentially people are collaborating in much finer grain. Or things like, voting was raised earlier. If, you have to tally, the votes from the entire United States, in the one day on election day, you can see what kind of rate you're going to need. But then you can also scale the system, taking advantage of the decentralization and so on, scale it out to meet those needs. So it really comes down to what is it you're trying to drive, and that's really going to be the ultimate driver of it. But you should be able to scale the system to the size that you need it.
You could use nested levels of blockchain.
Yep, that's a fair one too.
Tie in the really critical stuff, the identity, the authorization, into a Bitcoin style, but in terms of the actual bytes, megabytes, gigabytes, terabytes of data that you're distributing, that may not need as much as long as it's tied in reliably into
Yep.
your chain. Every time you write a file, it accesses Active Directory or LDAP or something like that. In Unix or Windows environment, doesn't mean that you need the LDAP environment to handle all of the data. It's just you're putting a higher level of trust there and a cascading trust.
Yeah, there's a protocol called Lightning for blockchain, Bitcoin style blockchain, that would allow you to extract high throughput transactions and then validate them on the main chain at certain checkpoints. And that might work in file systems. Because I'm right there with you in terms of using this with file systems. That's a great idea.
Yeah. So there was officially a sign. There's officially a sign saying that I'm out of time. I don't know if anybody knows. I know there's no talk after this. Does it actually matter if we stay a little longer?
Yeah, you should all get up
Okay, so I'll take one more question then.
Keep up.
Okay.
I don't have a question, but a remark. Coming from a medical company and having looked at blockchains for use for medical records, it may be nice to hear some reasons why you will not have it very soon.
I would love to, feel free.
First issue with blockchains is it's a public record.
Yep.
Which makes it really hard to keep things secret. Which does not matter for Bitcoin transaction, it's necessarily for property ownership. With a medical record, you don't
Yep.
want everybody to show.
Fair.
So there is a mismatch. We can do something about that. The second thing that we run into, in Europe we have a right to be forgotten.
Yep.
If you put something on blockchain, the right to be forgotten. You have the right to say to a company or to an institution, please remove all data you have on myself. If something is in a blockchain, you can never ever remove it. Everybody forgets about it. And the third thing, which is mostly with the Bitcoin sort of blockchains, is they're basically going to say, okay, these transactions, everything works because there is this democratic majority that votes on and keeps track of the system, and as long as the majority is okay with it, everything works out. Now, you have to think about, for example, your property rights. If you have a property right and you let a Bitcoin-like blockchain erase this, that basically means that suddenly a majority of anonymous people control what your property is or not. If a majority of these anonymous nodes suddenly decide that your property should not be yours anymore but somebody else, they can change this. The question is, does that make sense in any real-life scenario? Or should this be prevented? This is exactly why the
Hyperledger.
type of blockchains are, where the nodes that are participating, they are not anonymous. No, they are trusted people. They could be, for example, notaries or real estate agents.
Yep.
And they don't have to agree, but generally they have some form of, well, they do have some form of trust, more trust in a real estate agent that he works in this kind of system and trusting rather than completely anonymous person who just has a computer.
Yeah. I think those are all very valid points. And again, I mean, well, I may have presented these as perhaps a little bit closer to reality today than the truth, but I mean, you're pointing out there are valid concerns. You're pointing out again, the role of trust, the different roles in the different blockchains and so on. I think all those issues they're not insurmountable. They're not ready today. But again, I see this as, my personal thing is I think this is going to be a very transformative technology over the next 5-10 years or something like that. I think it's going to integrate in a lot of different areas. I think some people will push it into areas where a database will work fine. I think there are a lot of cases where a database isn't going to work fine, and these kind of technologies will shine, but it's going to take some time to address the exact kinds of questions you raised, and also for people to build up trust enough in this system to put medical records or property records in there.
I think just a comment. Estonia is one of the world's most digital societies. And they use blockchain for voting system, insurance, tax, tracking, everything.
That's Estonia, did you say?
e-estonia.com.
Okay.
Their display of
Yeah.
technology.
Well, Estonia is a rather small.
Yeah, absolutely.
Yeah. Okay, anyway, I see people leaving, so thank you all for your attention. Thank you all for the comments. I really appreciated that.